Hello student, myself Harish Raigor. I am from Gujarat, India. Today we will learn about what is the relation between Kp and Kc. It is the topic of chemical equilibrium. Chapter is chemical equilibrium and the topic is relation between Kp and Kc. What is Kp and Kc? Kp and Kc both are constant. Kp is called equilibrium. This is equilibrium constant. Kc is also equilibrium constant. But what is the difference between Kp and Kc? Kp where P stand for pressure. In terms of pressure, Kp. In terms of concentration, it is a Kc या फिर C. Concentration. Here we will see what is the relation between Kp and Kc. Before that, we see what is Kc, what is Kp. See here. If I write some reaction like R to P, R is called reactant, P is called product. Then we can write Kc is equal to concentration of product by concentration of reactant. This square bracket represents concentration in molarity. Next we will talk about Kp. If I write Kp, it is called partial pressure of P by partial pressure of R. Product, partial pressure of product by partial pressure of reactant. This P is for partial pressure. We know before that in this chapter what is partial pressure, what is concentration, what is molarity. Now we have equation PV is equal to nRT, which is called ideal gas equation. So if we have this equation, so here let's say A to B, this is reaction. Then what I can write Kc, concentration of B. Whatever the stoichiometry they have, we have to write it is in its power. So B is B power, A power. If I write for Kp, it would be partial pressure of B power, partial pressure of partial pressure of B power, partial pressure of A power. We have equation PV is equal to nRT, so we can say Kp, the pressure is equal to N by V. So here I extend this equation. PV is equal to nRT, where P stand for pressure, V stand for volume, N for mole, R gas constant, T temperature. From that I can say P is equal to N by V RT. We know what is mole by volume, it is called concentration. Okay, P is equal to CRT. If I keep this value, here from this Kp, partial pressure of B to B power, partial pressure of A to A power, P is equal to CRT. Then I can say concentration of B RT raised to B power, concentration of A RT raised to A power. What I written? This is okay. Pressure of B is equal to C for concentration in molarity. So molarity of B RT, molarity of ART, B power AR. If I take common this one, so the concentration of B raised to B, concentration of A raised to A, this will be RT. This B down A, I can say B minus A. This I can say B raised to B, A raised to A, RT B minus A. Now we can keep here relation Kp is equal to, what is this? Because this is called Kc. Before that, from this equation 1, this is called Kc. So if I keep value of this, then it is called Kc RT raised to B minus A. So from that we can keep the equation Kp is equal to Kc RT raised to delta Ng. What is delta Ng? I will understand. Before that, what is the value of delta Ng here? Just tell me. This is B, this is A. So I can say instead of RT B minus A, I kept the value of delta Ng. What is B here in this reaction? It is a stoichiometry of product. What is A here? It is a stoichiometry of reactant. Then I can say, I'm writing here. You can take a screenshot of this. Then I can say delta Ng is equal to gas product mole minus reactant mole. If you can say gaseous product mole minus gaseous reactant mole. Gaseous products mole minus gaseous reactant mole. Like for this equation, which one? Here one, whatever I write, AA gives BB. Here product mole, this against above one, this one is called mole. So this is B for product, A for reactant, that is called delta Ng B minus A, whatever I get. You just have to remember this equation. Kp is equal to Kc RT is to delta Ng. Kp is a constant for pressure in terms of gas, concentration for gas, R has a different value for in joule 11.314 joule Kelvin inverse mole inverse. R name is called gas constant. The another value they have 2 calorie Kelvin inverse mole inverse. One more is there 0.0821 liter ATM Kelvin inverse mole inverse. You can know this all three value of R. T stand for temperature. We will do one question. You will know. You just have to remember this formula. What is that? Kp is equal to Kc RT is to delta Ng, and this one. Just check one time that all things. Now we will take one question on the basis of this. You just have to remember this equation. What is that? Kp is equal to Kc RT raised to delta Ng. What is Kp? Kp is a equilibrium constant. Kc is also equilibrium constant. Kp is a pressure of product, pressure of reactant raised to whatever they have mole. Kc concentration of product, concentration of reactant, whatever they have stoichiometry. Yeah, you can say mole. If I take question from some IB board, then it will be just here. Like question you have, what is Kp? Just we will say unit of Kp and Kc. Kp unit I can say. Before that in reaction this one I write an AA and BB. Instead of I write Na gives Mb. Then what is Kp? The pressure of B raised to M, pressure of A raised to N. If I write pressure of B, then you can say delta Ng. What is the pressure of unit of pressure? Okay, ATM. ATM raised to M, ATM raised to N. Here if I write ATM M minus N, M is a mole of product, N is a mole of reactant. Then you can write unit of Kp is equal to ATM is to delta Ng. Same for Kc. This will be concentration. Then you get concentration of B is raised to M, concentration of A raised to N, concentration in the molarity. Then you can say mole liter inverse m by n is will be above m minus n, you can say mole liter inverse raised to delta Ng. This will be unit of Kp and Kc. For Kp, atm m minus n, then pressure should be in another unit also, it can be atm, bar, mini Hg. Kc, mole liter inverse raised to delta Ng. Question we take, if we have like what is it, Kp is equal to 2 into atm. Kp we have 2 atm. Kc is asked, and like they have written, the reaction is this one, like you can say 2A to 3B. What is delta Ng here? Tell me. It's a product mole. What is product mole? Okay, 3. What is reactant? 2. Delta Ng 1. So delta Ng 1. So what is equation we have? Kp is equal to Kc RT delta Ng. Kp is equal to Kc RT raised to delta Ng. We have delta Ng 1. We have Kp, Kc. Just tell me which R we will take here. Kp in a atm, Kc we want in a mole liter inverse. Then we will use this one, liter atm 1 unit. So here I keep value. This is 2 atm, this is Kc. R 0.082, you can say 1 by 10. Temperature is given, then it is okay. Not given, then you can say temperature 25 degrees Celsius for Kelvin, 298 Kelvin, 298, and delta Ng 1. Then after you can do this calculation, 2 by 0.082 into 298. This is Kc, mole liter inverse. What is unit Kc? Mole liter inverse delta Ng. What is delta Ng? 1. Then it will be this unit. But this is all done. Just you have to remember this relation. Kp is equal to Kc RT raised to delta Ng. Thank you so much.